In this video, we will demonstrate the execution of Emily. Emily is a unique capability that can process multimodal input, such as a video or an audio, and extract physical dynamics that is shown in that video. This is a execution of Emily on extracting the aerodynamics of a drone. So we utilize a video of a drone, and we utilize an object detection pipeline of YOLO, specifically the YOLO V8, and it detects a drone and it creates an XYZ time series of the drone. Then it also utilizes audio processing, specifically short time Fourier transform based methods, and it extracts the rotor RPM of the drone, and it also creates a rotor RPM time series. These two time series are provided as input to Emily. Now, what Emily does is that it extracts an aerodynamical model. Now, in this aerodynamical model, only the XYZ time series and the rotor RPMs are measured. But this aerodynamical model also has other unmeasured parameters which Emily can estimate. So Emily not only fits a model to the measured variables, but it can also estimate unmeasured variables. So in this video, we will see a demonstration of how Emily can extract the aerodynamical model of a drone as well as unmeasured variables of the drone. So here, this is the first component that extracts the drone's XYZ measurements and the rotor RPM by performing video processing and audio processing in a single pipeline. For the video processing, it utilizes YOLO-based object detection that detects a drone in a particular video and then tracks it XYZ positions. We try to extract the aerodynamics of this particular drone. So let me play the video that is the input to the pipeline. Now we run the drone video extraction pipeline, and in order to do so, we have a few inputs to this code. First, the video from which you are going to extract the XYZ coordinates, then a YOLO V model. Here I'm using the YOLO V8 model. This YOLO model helps in object detection, and then finally where you want to store the XYZ coordinates of the drone as well as the RPM values. So once we run this, it doesn't take much time. So the output of this code is a trajectory file, and in addition to those trajectory file, there are several other components such as these text files. These text files are in a format that can be accepted by Emily. So if you notice here, there is a trajectory CSV which has all the XYZ coordinates and the RPMs, and then there are individual files that are generated, the motor speed, XYZ data, and so on. Now, just to demonstrate what the altitude data extracted from the pipeline looks like, here is an example. As you can see that initially the drone was at a 0 altitude, and then the altitude increased and the drone kept hovering around this altitude with slight variations. Now similarly, we can also take a look at the motor RPM that has been extracted from the pipeline. As you can see, the motor revs up until the drone goes to a stable height and then slowly comes down. These are the inputs to Emily. Now we'll see how Emily can extract the a model, aerodynamical model from these data points. So Emily runs in a Docker, and currently Emily takes around 40 minutes to extract the aerodynamical model. But for the purpose of this demo, I only ran it for a single epoch, so it will extract pretty quickly. So here it uses TensorFlow to run in a GPU. So after Emily has run, it creates this coefficients.csv file, and that is a coefficient of all the parameters that is needed for a aerodynamical simulation. So these are the parameters that are needed for the aerodynamical simulation, and then this can directly go into a simulator that simulates the dynamics of the drone. This is the model that the simulator uses to simulate the drone dynamics. And Emily gives all these parameters such as CD, IBYY, IBZZ. These are related to the inertial coefficients of the drone that is extracted. Now, this model is then simulated through numerical integration. And this is an example simulation of the drone dynamics, where you can see that the drone is lifting off and it will stabilize at a height of around 15 meters. And the unique um, uh, property of Emily is that it not only extracts this XYZ positions, it can also extract unmeasured variables such as if we look at this, these are the position errors, and these are angular velocities which were not measured, but it was estimated from the Emily's implicit dynamics component. This is also Euler angles, the roll pitch yaw. These are again not measured. These are unmeasured parameters that are extracted. So this is the full pipeline that shows from a video how can we extract the drone dynamics and instantiate a simulator that not only simulates the measured variables, but also can estimate the unmeasured variables.